Okay, good afternoon. Welcome to Purdue University in West Lafayette, Indiana. My name is Michael Klein, and I'm the Senior Vice President for Administrative Operations here at Purdue. You know, in this capacity, my team and I are responsible for creating the built environment in which Purdue faculty, staff, researchers, students, along with industry and government partners can work together to successfully deliver on our education and research mission. So on a daily basis, my team and I are working to plan and design and construct, maintain and operate campus buildings and infrastructure. We have our own police and fire departments. We're thankful for that. We own and operate the Purdue Airport, and we also own and operate our own power plant, which brings us to today. Purdue is partnering with Duke Energy to do a feasibility study to explore if it's practical for us to consider advanced nuclear technologies, such as small modular reactors, as a potential long-term solution for our energy needs. Thus versus staying with our existing power plant technology, which burns fossil fuels. Part of the study includes conducting a series of public lectures, which we have titled Understanding Tomorrow's Nuclear Energy. Today is our 6th lecture. I think you just saw a little short video about the previous ones. And we've elected to do a panel discussion with industry experts. We'll get to that in a minute. So we've been working diligently on this since last April, but we started our lecture series in June. I do want to take just a second to thank Stan Pinniger, who's president of Duke Energy Indiana. He's with us today, and they've been working so well with us on the study and to coordinate our efforts with Duke's nuclear team that's located outside of Indiana. So this is a partnership that we have with Duke Energy. Here's a quick summary of what we just walked you through on the video, and it really an all-star cast of people that have been here to Purdue to help us create some public awareness about new nuclear technologies. Just a couple highlights of some of the things we've picked up along the way. I think that there's a tremendous need for the private sector to get involved and help with this, and they're doing that on the innovation side. Many vendors are developing SMR designs that are going to be out there for potential and future use. Also want to say that the SMR technologies that are emerging are much safer than legacy designs. And I would point out that, you know, in the two bottom bullets there, that, you know, these are suitable for consideration for replacing retired coal sites, and that much of the workforce in existing utility industry could move into nuclear. I think that one of the drivers for Purdue in starting the study was that we're interested in the decarbonization side of it. There are a lot of good reasons, but you know, we believe that at scale it's going to be very difficult to decarbonize without nuclear taking a larger role. I also think that as you think about, you know, maybe the hurdles, and the panel will talk about this in a little bit more detail. You know, supply chain challenges, that's kind of new in the last couple of years as being highlighted in a lot of things, but it's true for nuclear. And workforce development, we have this emerging need for nuclear energy. There'll be a workforce development component that's going to be vital to its success. Lastly, I would say that the research universities, you know, which Purdue is, of course, one, will play a role, and you know, partially in the research on technology, but also the training ground for professionals that will create our clean energy future. So I think at this point, I'd like to go back to my agenda here. It's evolving. I'd like to go ahead and introduce our panel moderator, and that's Chris Nolan. Chris is the Vice President of New Nuclear at New Nuclear Generation Strategy and Regulatory Engagement for Duke Energy. He's also one of the principals on this SMR study that we've been working on with Duke. Chris joined Duke Energy in 2006 after working at the U.S. Nuclear Regulatory Commission for 9 years. At the NRC, he served in various capacities of increasing responsibility, including being the chief of the New Reactors Environmental Projects Branch in the Office of Nuclear Reactor Regulation. Additionally, Chris is a qualified operator in the U.S. Navy's nuclear power program while he was employed at the Knowles Atomic Power Laboratory for General Electric and is a graduate of the U.S. Navy's Nuclear Power School. We are honored to have Chris here with us today to serve as our moderator for the panel discussion on implementing advanced nuclear technologies. Please join me in welcoming Chris Nolan.
Mike, I appreciate your kind words of introduction and appreciate the audience's attendance. We have a panel session designed today. We got a number of questions from the audience that will guide the panel session along. But what I first wanted to do is introduce the panelists. They'll come out as I introduce them. So the first is Tim Hanley. He's the Senior Vice President and Chief Operating Officer of Constellation Nuclear. He is responsible for the operation of 21 reactors in the Constellation fleet. Prior to his role, Tim was the Senior Vice President of Operation Support, where he was responsible for the corporate functional areas and provided governance for the Exelon nuclear fleet. Prior to that, he was the Senior Vice President for Special Nuclear Projects. Previously, Tim was the Senior Vice President of Western Operations for Exelon, and he's also held previous positions as the Site Vice President of Quad Cities and also the Site Vice President of Dresden. Thank you for being here, Tim.
Thanks, Chris.
Next, I wanted to introduce Luis Reyes. Luis has over 40 years of experience in the nuclear power industry. He was a senior leader in the U.S. Nuclear Regulatory Commission, the top federal government nuclear safety regulatory agency. Luis holds a master's degree in nuclear engineering from the University of Puerto Rico. As a graduate nuclear engineering student, he was actively involved in the university's reactor, conducting tests and research. Upon graduation, Luis joined Argonne National Lab as a nuclear engineer in its experimental breeder research reactor 2 program. Thank you, Luis. And next, I wanted to introduce Ahmet Kopinar. He is a Bechtel Principal Vice President and General Manager of Bechtel's Nuclear Power Business Line. His portfolio includes oversight of new nuclear generation, advanced reactor development, and major modification services in the U.S. and worldwide. Ahmet is an accomplished nuclear power professional with 30 years of experience. He has extensive knowledge of the nuclear power market sector, project execution gained from leading business development and commercial activities for Bechtel's nuclear business line throughout the last decade. Welcome, Ahmet. So really to kick off the questioning, Luis, I'm going to ask you a question that I get asked quite a bit as well. I understand the importance of regulatory stability in the deployment of new nuclear plants. What lessons have we learned from the past, and what will NRC need to incorporate into the future?
Thanks, Chris. Let me give a little bit of background. The United States has the largest nuclear fleet of commercial plants generating electricity, 92 units in the country, very reliable, very high capacity. They're all of the same technology. We refer to it as light water reactor technology. The U.S. Nuclear Regulatory Commission, the government nuclear regulator, is considered the gold standard in the world for nuclear regulation based on its number of engineers and scientists. It's been in existence close to half a century, and it leverages national laboratories and efforts from universities like Purdue. Before the meeting, we had the opportunity to tour some of the facilities where Purdue partnered with the NRC to help develop codes. Now, the regulations in the U.S. are very deterministic. What do I mean by that? They're written in a form that says you need one of these, two of that, and they were designed for this light water reactor technology. Now with the new advanced nuclear technologies coming forward, there has to be a significant change on that infrastructure of regulation. The NRC has identified there's two particular tools that the industry uses to apply for construction permits and operating permits. They're referred to as Part 50 and Part 52. So the NRC has identified over 100 changes that need to be incorporated to those regulations in order to make them suitable to expedite the processing of these applications for advanced nuclear technology. And they're working that particular effort. There's also other regulations that have to be changed for conformity to make sure that is supported. This is a large effort, and like other industries, it requires a lot of resources, specifically nuclear engineers. So if we have any nuclear engineers in the audience, great opportunities, a lot of activities relating to that effort. Several lessons learned from the previous licensing of other designs, earlier designs, are assigning teams, different teams to a particular technology, so you become more efficient in doing the reviews of the licenses, and they are preparing to do that. The challenge the NRC has is, at the same time they're changing all those regulations, the applications are coming in. So you have to do two things. You have to change your infrastructure, change your procedures internally, apply the lessons learned from the past, and at the same time, try to process all the applications that are coming in.
Thank you, Luis. Ahmet, I have a question. Bechtel is involved in the construction of Vogtle Unit 3 and 4 near Augusta, Georgia, as well as international projects. What are some of the key takeaways that we have learned regarding construction?
Thank you, Chris. And before I answer that, I'm going to come back, Luis, what NRC is doing. I think there are a couple of very critical initiatives, decoupling energy island from the nuclear island to reduce the NRC oversight on advanced reactors. A couple of technology companies leading this effort. I believe it's with NRC in terms of topical reports. What it would do is, if NRC agrees, they would have no jurisdiction over the energy island of the plant. We would be able to build those parts of the plant, just like we're building a combined cycle plant, to very standard compliance and requirements. And that would be a significant gain in productivity, that will factor into the overall cost of the nuclear plant. I just wanted to touch on that. So what we're doing, we took over Vogtle 3 and 4 in late 2017. By one account, we were the third construction contractor. We did not have any design scope. Our scope was limited to different commodities. And, the idea is Unit 4 is design complete, which is essentially this. That would become a reference plant. And that reference plant will be the basis of the next AP1000. Now, there won't be a next AP1000 in the U.S. for a variety of different reasons. The U.S. demand is not where Europe is looking today. U.S. is more focused on waiting to see how the SMRs and advanced reactors are going to develop. So what we're doing right now, it's prudent on us as an industry, look at what we've learned over the past decade, and what are the things that we should be doing differently, such that the SMRs, by the way, I call SMRs small modular light water reactors. In the industry, they use interchangeably sometimes, and when I say advanced reactors, they are water light reactors, like lead-cooled, sodium-cooled, or salt-based. They're the next phase of the reactor fleet. So if we look at those, we've come up with some key principles that we are now applying in our joint project called Natrium in partnership with TerraPower. Natrium is a TerraPower technology. It's a sodium-cooled fast reactor with an ability to store thermal heat in salt tanks. So the heat from the reactor doesn't go to a turbine, it goes literally to a tank. So you can generate baseload energy. You know, the salt, there's a salt to water heat exchange, so you have your baseload of 345 megawatt electric baseload generation. And when the renewables are down, you can pick up to 500 megawatt electric for 5.5 hours to meet the peak demand. So it's a pretty neat concept. So how are we designing it? You know, one principle is do not mobilize for safety-related construction at the site until the design is complete, right? You're going to say, well, this is no-brainer, you know. Why are you telling me? We must have learned it 100 times before. Well, unfortunately not. You keep seeing this on many projects, not just necessarily nuclear, you know, going to the field, especially on a first-of-a-kind application, before your design is complete. You know, there are reasons for it. You know, there's always a driver. You want to reduce the overall project duration, minimize the development costs during the initial phases. And, you know, to our surprise sometimes, there's a lack of understanding on what is design completion. How do you define what a design is complete? You know, from an EPC perspective, this is very easy. When a design is issued to construction without any holds, that design is completed. A construction guy can take that design and go build it. But you'll be surprised if you go discuss with AEs and customers, and they may not have a straight answer how that defined. Second one is there's a tremendous opportunity when you're developing a new design, first of a kind, like Natrium. Do real constructability reviews of the design. I mean, engineers are great, you know, but they may not have the experience or the context of what they're designing would actually work in the field. We are a design and construction integrated organization. What we do during early design, when I say early design, I mean like when we start conceptual design, we have key construction guys sitting in the office looking at every aspect of the design to ensure it's optimized and it can be built in the most efficient way. So there's a lot of iteration going back and forth. And that's vetted. And I'll talk about some digital tools that help facilitate those reviews. You don't want surprises when you're in the field, you know, something that is not constructible, you have to tear it out, reinstall it. A day you lose at the site at the peak could be in tens of millions of dollars a day cost, depending on the size of the project you're building. When you're in the office and you have a couple of construction guys doing this, yes, you're spending a little bit more upfront cost, but you are saving tens, hundreds of millions of dollars of cost, depending on what the issues that you would face. Fourth is, you know, not a novel concept, you know, digital tools are available for the industry. You know, the nuclear industry been pretty late in adapting, and on the jobs that we were involved from start, we never had the chance to go to the site. The programs were canceled. We worked on Empower with BMW for 4 years. There was no funding left. We had to stop. We worked 2.5 years with Hitachi on the Wilfa project. We started on the same path with those principles. They ran out of money, the project got canceled. So when you look at the US industry, there were only 4 real construction projects, you know, VC Summer and Vogel, and nothing planned next that would really take that lessons learned, the de-risking of all the components, the technology approaches, and benefit the next one. Hopefully, we'll take it to Europe, and I'll get to Europe at a different question. So this digital integration is nothing more, taking a 3D model, creating a common data environment, and then bringing your design engineering tools, digital procurement tools, construction tools, they all integrate and utilize the data from the common data environment. So you have a single source of truth and data. You're not duplicating anything. All your 2D drawings, your PNIDs, they're all stored in one place with configuration control. I cannot emphasize the amount of rework this eliminates when all your tools using the same data, whether it's the vendor data, but you got to be disciplined and you need to set it up. There's some setup cost in the beginning, but it is definitely pays off. We do this on our LNG projects, petrochemical projects. It makes a difference. Modularization, I think there may be a question coming up on that. That's great. There are many factors you need to consider. If it's a high cost, low availability of skilled labor, you definitely want to look at it. But just like you need to take constructability into it, you need to do the cost and trade benefit analysis. Does it work it? How does your supply chain look like? Do they have the quality program that you can rely on them fabricating this right, so when it arrives at the site, you're not fixing the issues at the site, because now you defeated the whole purpose. It's costing you more money. The last thing I want to mention is, we have this, what we call advanced work packaging that we integrate with the 3D model and then utilize the 4D model. And the whole idea is, rather than wait to mobilize at the site and start developing construction work packages that the field engineers and the superintendents would go implement, you start doing that during the design phase in the office. Yes, you're spending more time and money upfront, but you have these key guys, construction guys. You can map your the scope from the 3D and say, here's how I want to build this room. You're tagging it. You are using the 4D visualization, which is a simulation of the construction process. So you can see the sequences, resource clashes, and you can create a package in a data environment. Then you mobilize, you pull that data in with detailed instructions and give it to the craftsman. Now they have an electronic version of everything they need with really good instructions, detailed instructions. It reduces their time on tools, especially with inexperienced craft, gives them more. In today's world, you go to the field with binders of information, especially on the nuclear side of the business, and imagine how much time a superintendent loses trying to get the drawing or the information. So this is going to change. I believe it's going to be a game changer in the nuclear part. We're doing this already on non-nuclear projects, but hopefully Natrium is going to be the first to implement. And then lastly, the nuclear quality, nuclear safety. This is very, very important. If you don't set up that culture right from day one, it is extremely challenging to set it up. When we took over a construction project in the nuclear sector, and we see that the culture is not there, it is pulling teeth. Changing culture, establishing a new culture is easier than changing an established culture for compliance. So that's one of our now, new playbook is, we set these, we call them schools, both safety and quality, but also skills training. You want to make sure that, before these guys turn a wrench, they not only understand the safety quality requirements, they're skilled. I think that's helpful. Maybe
Thanks,
I
Ahmed.
may have run up my time, but
So Duke very much is interested in standardized reactor designs. But the concepts that you were talking about is taking that standardization into construction, I think is really important to maximize the efficiency gains from the first to the second copy. And I think that would be good for the industry overall. And you mentioned the Natrium design. Duke's one of the partners on that ARDP project. And the integrated thermal storage is a really exciting concept because it allows us to pair nuclear with variable renewables like wind and solar and make both more valuable. But, you know, that's an energy security discussion, and we've got a question later on that. Tim, I wanted to pivot to you. We got a question from the audience, and I want to recognize Constellation as the largest nuclear fleet in the country. And can you talk about the role of nuclear within Constellation and achieving carbon goals, and what support is needed to maintain your fleet viable for the next 30 to 50 years?
Yeah, thanks, Chris. Yeah, to go back a little bit, just to give you a little bit of background, most of my job when I was the Senior VP of Nuclear Projects was working with the states, individual states, in particular New York and Illinois, where due to some market issues, those plants just weren't receiving the return that we needed on them. You know, that patchwork of state legislation, short term, worked in the short run, but it wasn't a viable solution long term because you do need to make capital investments at the plant, and you need to be able to plan those over a period of time. The big game changer, of course, was the Inflation Reduction Act that was passed last year. That supports all the nuclear plants and really sets kind of a floor on what the price of power will be for nuclear generation. With that, you know, from 20 to 21, I spent most of my time trying to figure out how I was going to shut down the 11 nuclear reactors in Illinois by 2027. And now we've already announced we're doing license extension at Clinton Station, which is it'll be its first license extension, and second license extension at Dresden, both of which, you know, prior to the Inflation Reduction Act, both of would have been shut down by the end of this decade. So I think that's a really, really, really good start. There are some plants that are going to be challenged. The small single unit plants, I think, are still marginal, so we'll have to look at those as they each come up. But the big thing that we need is for people to understand that we can't shut down another nuclear power plant in the United States and even hope to achieve our carbon-free goals. It's just impossible. Wind and solar have a very viable part in that, but they're not dispatchable. You need electricity when electricity is going to be used, not just when the wind's blowing or the sun's shining. So dispatchable, you know, means it's there when it's needed. And nuclear is really the only carbon-free generation source that is fully dispatchable. And so that, for us, you know, that is our goal. We just announced a few days ago, we're investing hundreds of millions of dollars into our Byron and Braidwood units to do not thermal upgrades, but efficiency upgrades, which will generate another 135 megawatts electric from those 4 units. So I think, again, it's a great start. We intend to be not only a zero carbon company, but there's technologies that we actually think we can reduce the amount of carbon. There's air capture technology, carbon-free air capture, and essentially you add chemicals to water that flows down as the air goes up. It scrubs the CO2 out of it. What you need for that's a large cooling tower, and we happen to have those at a number of our nuclear plants. So we actually believe not only can we get down to no carbon generation, we can actually reduce the carbon that's already there. For Constellation as an entity, nuclear is 90% of our business, so it is absolutely essential to us, the long-term viability of all of our facilities.
Thank you. At Duke, our nuclear fleet is 82% of our carbon-free energy, and we're looking at subsequent license renewal for all of our plants for the very same reasons, to keep them in place to help us achieve our carbon goals. And the Inflation Reduction Act just just makes the financial equation much more
Exactly.
positive. So, I think Congress had a lot of foresight in trying to lay out the rest of the century in terms of how we would get there. Luis, I've got a question for you. Can you share your perspectives on community engagement, public acceptance, and siting in context with the licensing process for future deployment?
Good question. When the government grants a construction permit or an operating license to a nuclear power plant, it's called a major agency or government action. And that legal term, what it means is that you trigger the National Environmental Protection Act. And that act is very prescriptive, not only on the technical matters that are going to be reviewed, but how the communities are going to be involved. And it requires that at the beginning of the process, the NRC will hold public hearings in the nearby community where the plan is being proposed, get feedback from the community on any concerns they have, environmental or otherwise. Once the review is done and the report is drafted, it goes back to another set of public hearings in the community, shares the report, and makes sure the concerns and the issues are dealt with. So that's the formal licensing process. Separate and apart from that, typically the organization that's applying for the licenses, typically a utility, will also hold meetings in the community to educate, inform, and understand any concerns that are there. Now, the dynamics are different in different geographical regions of the nation. We have states where more than 50% of the generation, electrical generation, is from nuclear power plants. So the public is very aware of these facilities. They have been there for decades and decades, and they're informed. They have visitor centers that they go and visit. If you're in a regional area or a state that doesn't have any nuclear power plant, it may be advisable to just have a proactive approach in terms of informing. And just like this series of lectures where we're sharing with you a lot of information, is the same kind of thing that the average citizen will like to understand and express any questions or concerns they have. So I think depending on the regional area where you're proposing or considering a nuclear facility, you need to address that in a more proactive way. My experience has been that typically the public is interested in information and education because if they haven't seen such a facility, there's not one in the state, they haven't had the opportunity to be involved with that.
Thanks, Luis. And as a follow-up question that we got from the audience, do you see the SMR as a practical solution for powering a large university like Purdue? And if so, are there any SMRs being planned or built?
Yeah, several questions there. First, the original design or desires for these vendors was the purpose of producing electricity. And it was mentioned earlier, if you look at the future and you assume a high penetration of renewables, which are variable generators, right? I mean, the wind may blow or not blow. You may have a day like today where it's cloudy and the solar panels are not going to be as efficient. So you need a base generation that's always available, and Tim used the word dispatchable, so it's there for you to supplement your renewables. And that was the original concept of these technologies. There's a desire now from a lot of industries to also reduce their carbon footprint. And we see chemical industries and other industries now moving forward to try to use SMRs as their energy producer. Most large chemical plants and industrial facilities use steam heating and steam for the different chemical processes. and and electricity, of course. And so there's at least one proposal already. Dow Chemical has publicly announced their intention to move forward using an SMR technology to support one of their chemical facilities. And there's quite a few others that haven't publicly announced it but are being considered. So a facility like a large university could definitely use the same concept, electrical generation, steam generation, to support their energy needs. The question will be, how do you fit it? How do you interface with the local utility? Do you have the terrain and surface area that you own that you can locate it? But there's no reason why it couldn't be done. I think you're going to start seeing announcements of SMRs being paired with a lot of industrial facilities. If you look at the large steel manufacturers in the U.S., they all want to have their steel to be green, clean. And so steel manufacturer, smelters, aluminum, they use large amounts of electrical energy in their processes. And so most of them today are being supported by coal power plants, and they are interested in making that transition rather quickly. So I think you're going to see also, and there's an interest to start going up on hydrogen production. So you could use SMR to either electricity, or when you don't need electricity, you can produce the hydrogen. And of course, the hydrogen is now being considered as a fuel for many uses, like heavy transportation, among others. So yeah, I think there's potential to apply that technology to such a facility.
Thanks. If you think broader than just the utility business, right, and you look at the carbon economy, a third is transportation, and you see electric vehicles increasing their market penetration. A third is utilities, so we have some experience with nuclear, and other utilities can learn from the ones that don't have the experience, can learn from the ones that have. But really the industrial sector is the one, and I see partnerships between industrial customers and utilities, and as well as ones that are going to try and do it themselves. And I think that's the most dynamic part of the future equation on how to achieve that. Hydrogen is also very interesting because, for a utility like Duke that has a lot of gas turbines, it allows us to reuse that infrastructure and reduce the cost of the energy transformation to our customers. So Tim, I had a question for you. The Advanced Reactor Demonstration Project has provided government funding to reactor vendors to accelerate technology. And the Inflation Reduction Act provides tax incentives that reduce the cost of the transition to our customers. What will it take for utilities to go forward with the deployment of new nuclear technologies?
In really simple terms, I think it's the affordability. There are the DOE-funded projects that are going forward right now for the demonstration reactors that I think will go a long way in showing, can we build it affordably, is it viable? And we all in the industry need to make sure that those are successful. My company itself, we're a merchant generator, so we're not actually tied to a utility. Everything we produce, we sell in the open market. And so we'd have to look at the return on equity, but even a standard utility that is generation, transmission, distribution altogether, they need to look at it, how does that investment compare to other investments that they would make with the shareholders' money, because we're all generally shareholder-owned. There's municipals and things like that. But I think it comes down to proving that it can be done, proving it can be done affordably. But when we were talking earlier at lunch, some of that is we do need to look at it as a long-term investment. The nuclear plants that we have now have operated, almost all of them, 40 years, and most of them have been relicensed to 60 years. A couple have been relicensed to 80 years, although there's some things we got to fix on a couple that have been not done with that. But so there is really nothing. But if you're looking for a short-term return on investment, because even the SMRs are going to be very capital intensive at the beginning to build them. And you got to look at that investment over time and how that plays into it. So I think the first two demonstrations are going to have to be successful, and we all need to work to make sure they are, and then look at the affordability. And again, the learning from it. Like I mentioned, what can we learn from those two things to make it better, faster, and are there regulations that we need to change to make that, that work affordably too? The current regulations that Luis mentioned are what the NRC has to work within. And so they have to go through a rulemaking process if they're going to change those. It gets public input, it takes time, and they were really geared towards the larger light water reactors that are currently in operation. So I think there's a number of different things, but I think it's the first successes, and then you'll start seeing more and more people get on board.
Thank you. So Matt, the small modular reactors are smaller than the existing fleet, so they're less expensive to build. They're also modular, which is expected to reduce the time for construction. What's more important, small or modular?
I think they're both important, but the small has other unique, attractive aspects to an older developer, right? Small, less capital intensive, easier to build, more predictability on construction schedule and construction cost, everything else being equal. But then on the downside, you're really not getting the same economies if you're building a gigawatt scale. So it really depends on a customer's needs where, it may make sense to build a single, if you're building a fleet, the math may look different. But in either type of technology, I think, modularization in construction is not a novel concept, okay? It's the application in the nuclear industry is relatively new. Westinghouse, a large reactor, they have a very highly modularized approach, civil, structural, mechanical, electrical. They had, had to work through the learning pain, first of a kind design issues, fabrication issues. They worked it out. They have a good supply chain. So the next project that we go to, hopefully in Poland, there's going to be significant benefit from that. On Natrium, we're looking at, steel, plate, roof, walls, floors, staircases, steel composite walls for the reactor area, working with some of your professors here. Electric modules, the houses that you can keep, medium voltage, low voltage, switchgear, MCCs, with all the terminations in the tray, huge savings, especially you save critical electrical resource at a site, and that can come in shipments. In all of this, the one lessons learned is, A, make sure that where you are proposing it makes sense. You don't want to modularize anything in the Middle East or in Asia where labor is cheap. So that's one. The second is, it's like you still have to do the constructability to make sure that the modules you're designing will have the tolerances that can be installed easily. It's not going to create a problem. That there's a cost-benefit analysis that favors, modular approach. And you have the fabricator and the supply chain that you have the confidence that you can either develop or ready to do quality job, that you can set up the quality culture, the compliance, whether you're in the field or in the shop, it doesn't change. You can make mistakes there because there's nothing worse than getting the fabricated module at the site and it has mistakes, it has defects, it's missing parts, which happens, then you're paying through the nose again. You want to minimize any rework at a site. It is very expensive. We call it the hotel load. You know, depending on how big your project is, it could be a significant amount of money per day that you're burning every day you're late.
It's interesting because everyone talks about small modular reactors, and Ahmed mentioned the economy of scale. That's what happened with the original reactors. The new small modular reactors are actually larger than the original reactors at Dresden 1, Peach Bottom 1, Shippingport. So I think when you look at it broadly, the modularization is very important, but does it make a lot of sense to build one small modular reactor anywhere, or should they be ganged together where you go through the siting permit one time for a number of reactors? And there are advantages right now. If you lose a gigawatt reactor, that's a lot of electricity that comes off the grid very quickly. Where if you had it divided between a number of reactors located centrally, you get better redundancy and better reliability. So,
Yeah.
So how do we transform the concept of economy of scale to economy of number?
Right.
And when you think about a large number of small modular reactors, one of the thoughts that come to me is supply chain. So I think the audience might be interested in your thoughts, Ahmed, about the ability of the supply chain to support the deployment of new nuclear plants, whether it's people, engineers, welders, health physicists, components, long lead items. Where do you see some of the major challenges?
So I mean, you need to ask this question: what is the environment we are operating under? Are the projects free to source their equipment and supply globally? Or are we restricted per whether it's the DOE requirements, just like in the OIRDP process? And when I look out in the next 4 or 5 years, I see maximum 4 projects: Natrium, X-Energy, TVA with their GE, and then maybe NuScale, maximum. I think there will be a supply chain to meet them, their demands. They'll buy some, they can't demonstrate it's in the US, they'll buy it globally. Now, the bigger challenge that I see is really the lack of skilled construction workforce in the US. So I was reading a study that, you know, we're party to a subscription service. They look at the plant spend from Inflation Reduction Act, Infrastructure Act. You know, they piled up all the projects, you know, the EV batteries, you know, car, semiconductors, and then the spend shows in the next 4 years, there will be 3.5 million construction workers short. This is non-residential workers, commercial, industrial, you know, infrastructure. Now, so that's one. This is net of attrition. The attrition, you know, in 2008, about 1.5 million construction workers left the industry. This is the 2008 financial recession. And they didn't come back. And since the attrition is really on an accelerated path, one example, the projection is by 2025, 25% will retire of the existing construction workforce. By 2033, 47% will retire. Now, so that's the part you're losing. If you look at what it takes to, you know, bring a productive construction worker to a productive state, that's 7 to 8 years, 7 to 9 years. And construction is the least attractive work in the industry, even though it pays more than most professions. So something has to change. I mean, we're looking at it. We're working as a, you know, we work both union and non-union with the unions, you know, in different jurisdictions. You know, what do we need to do? But I think the federal and the state governments needs to have programs that allocate funds for training and development. So this is not an easy problem that we're going to solve with one company or 2 companies. This has to be an industry-wide effort that we need to launch. Now, the good, because the four that are out there within the US SMR, advanced reactors, they are relatively smaller in size. If the Natrium project requires 1,500 craft at peak, at Vogel we had 5,000. And believe me, when you're talking about skilled labor and you're struggling to get electricians, we need 400 on Natrium, we needed 2,000 on Vogel. Okay, huge difference. So the incremental impact.
Your microphone fell off.
Whoop.
That was intentional. But thank you for catching. All right.
Yeah, the last number, can you repeat the last number?
Electricians.
Electricity.
Between
Yeah,
Vogel and
so on a Vogel project, it was a 2-unit site, but we had, our peak need was 2,000. We could never get it. Never get there. There's always been attrition. On Natrium, it's a smaller job, and the advanced reactors, I think this is a very important feature. They have so much passive components. There is less operating equipment, less valves, less actuators, less cable, less terminations. So the amount of quantities you're building, installing, is far less compared to a traditional light water reactor. And the sodium reactor operates at atmospheric pressure, so you don't have heavy wall pipes. Your reactor is not 6-inch steel. It's 2.5-inch steel because it's not pressurized.
Thank you. So Tim, audience members want to know if nuclear energy is the ultimate answer to avoiding global warming. And can you talk about the importance of nuclear in providing energy security in a carbon-free future?
Yeah, for the first part of it, I think it almost has to be. We talked a little bit earlier about electrifying cars. Something's charging those cars, right? And if it's gas or coal, all you've done is trade the emissions from your automobile for the emissions of the plant that's charging them, which may be better, but it's certainly not carbon-free. And I think that's a lot of times missed. Again, the penetration of wind and solar, while it's very important, when you get up in the morning, you want to take your car and drive to work. If the wind didn't blow overnight, you still need your car charged. So again, the dispatchability of baseload generation like nuclear that has to be there when it's demanded is important to everybody. You don't want to wait until the sun's come up to turn on your microwave, right? I mean, it's those kind of things that I think, and really, nuclear is the only carbon-free generation that's around. You talked about some of the other industries. The one industry that there isn't really a good solution for at this point is the airline industry. You can put batteries in cars. You can't put enough batteries in an airplane to make it fly. It just becomes way too heavy. And so there is technology to use hydrogen to make jet fuel, but something has to power the hydrogen facility. And if it's anything other than nuclear, again, you're trading emissions from the jet engine to emissions from whatever plant is powering them. So I do think nuclear is the ultimate, the only thing we have right now. There is just not storage enough or enough wind to do that. What was the second half real quick, Chris?
It was, can you talk about the importance of nuclear in providing energy security?
Absolutely. I think it's been very demonstrable in the last year with the unfortunate issues in Ukraine, how heavily reliant Western Europe was on getting natural gas from Russia. And while we have a lot of natural gas here, we have a lot of coal here. If you want to do it carbon-free and separate yourself from being dependent on other countries for your energy security, nuclear is the way to go. There's an abundant supply of uranium that we could use for literally thousands of years.
Great, thank you. And just a follow-up question, how do you see SMRs affecting the affordability of clean energy?
I think it's everything we've talked about recently. Are they constructible? Do we have the craft to do it? Do we have the supply chain? I think the supply chain issue solves itself if there's enough demand. It's the issue I think that partially was run into at Vogtle. If you only want 2 pumps and you're a pump manufacturer, you kind of go to the end of the queue. They're going to go to some other, it may be a petroleum plant that wants 20 of them. And so if you get a standardized design and you can go to a valve manufacturer and say, over the next 5 years, I want 500 of these, they'll move you to the front of the queue. So I think it becomes self-fulfilling and lowers the cost. Every time you build a new one, you get lessons learned. You got to resist the temptation, though, of changing them with every time you build a new one. I think you need a standardized design that you stay with. The French were very good about that with their fleet. It saves in a number of ways. But it also, again, affects the supply chain issues, because if you're the supplier and you know you've got a long-term buyer, you're gonna move that person up, and it actually will lower their costs because they can produce them in a mass format than a special order type of format.
Well, very well, thank you. And that kind of brings us to the conclusion of the panel session. I wanted to thank all the panel members for their participation, and as a special treat, I believe we have the University President Mung Chang here to provide some comments.
Thank you. Well, now you have a non-expert on stage. But I just wouldn't want to miss the opportunity to come here and first of all say thank you to Mike Klein for his outstanding leadership here, and thanks to the entire panel here, moderator and the panelists, for a very lively discussion. Was able to hear part of it back in the green room over there. And also want to recognize a lot of outstanding leaders from the university and the state, including Representative Saladay here. Thank you. We acknowledge the fantastic partnership with Duke Energy. Without Duke, we will be quite a bit more academic in our thinking and conversation here, and now it is truly a partnership between industry and academia. I just want to reiterate 2 points, perhaps, that President Daniels last year and others have already been describing to all of you here. And the first is that Purdue University thinks sincerely and seriously about a renewable future. And one cannot be sincere and serious at the same time about such a renewable future without at least paying some serious attention to the possibilities of nuclear energy. And when we think about renewable, scalable, affordable, then we have to think about all types of opportunities. And indeed, this country and the whole world over the past 12 months or so have been much more receptive to the conversation that we have been having here on our campus today. And 2 is that we have a lot of questions, and that's why we have the expert panels today, and that's why we have been running this whole series of thought leadership, open dialogue with students, faculty, staff, neighbors in our campus and nearby communities, because we want to learn more about it ourselves. We want everyone to have a chance of open, transparent dialogue with true experts on all the dimensions involved, including technology, economics, and regulation. On the technology front, we are learning a lot, certainly for non-experts such as myself, about the next generation, about small modular reactor in particular. And how does small help in this case? How does modular help in this case? And how is this different from the current and previous generations of nuclear power generators? And when are we going to be ready in different technological specifications? The economic side is also important, that we cannot overlook the financial aspects in the operation and in the recurrent and the future cost and savings. And then on the regulation front, we all would like to understand the safety features, including safety during construction, safety during operation, and safety post-operation, including the processing and disposal of the material. And those safety aspects, rightfully so, will be clearly regulated by different federal and state level authorities. What we hope to have a better understanding and clarity is in the continuity of such policies and in the clarity of the regulatory environment. It will be much harder to dive in when the goalposts will be changed every now and then. Then you never know when is the project going to be completed. So that requires a dialogue between experts and the policymakers. So we're going to continue to learn more about the technology side, the economic side, and the regulation side. And today's outstanding panel is an important step along that direction. So as we continue this journey, we will have other means of communication with the neighborhood and with students interested in this area, whether you're a nuclear engineering student or not. It will be totally fine if you are. But then again, I know that we have outstanding students who are interested just in the topic from many other angles. So there will be other channels to have those communications. And in the meantime, we also have a technical advisory group consisting primarily of our faculty members, experts in nuclear engineering, in material engineering, in civil engineering, and related disciplines. And they are raising a list of questions. We're trying to get to the bottom of the answers to those questions. So as we continue this journey of working together, we will be updating the community very frequently and regularly. So with that, I would like to invite two more of our dear friends and colleagues on stage to wrap up today's event. First, we'd like to acknowledge Representative Soliday and invite him on stage to say a few words. And then perhaps our outstanding SVP, Mike Klein, can come up and help us conclude today's panel. Thank you again very much, and Bola.
Well, thank you, Dr. Chang and folks from Purdue. I had an uncle who was a research engineer, and when I was 12, he said, you know, we can do almost anything from an engineering perspective. Now, the politics, that's a very different story. So about 4 years ago, the governor's office asked Senator Cook and I to come up with an energy policy for our state. So for the last 4 years, we've taken over testimony from over 200 witnesses. And we came to 5 pillars for energy for Indiana. It's got to be reliable. 70% of our electricity in the state goes to business and industry. It's got to be affordable. We have to be able to afford the electricity. We're seeing what's happening in Europe with hugely accelerating prices, which again hurts our ability to manufacture. Then it has to be environmentally sound. 100% of the new businesses who have shown an interest in Indiana want renewable energy, but they also want reliability and affordability. And then we need resilience, the ability to recover from off-nominal events. We see more and more of those. We can't. I happened to be at Nucor last week, and about a 2-minute interruption, the impact upon their ability to make steel was just phenomenal. I watched people go from relaxed to animated because of what could happen with that interruption. And lastly, stability. Industry today needs stable electricity. When an airplane flies over, a large airplane flies over the solar array at the Indianapolis airport, the voltage and frequency fluctuate. And that probably doesn't matter in my neighborhood where we read books and watch television. But believe me, it matters when you're making microchips. Just a short interruption at one of our, in voltage and frequency, at one of our pharmaceutical manufacturers is $100,000 worth of pharmaceuticals that fast. So it's an interesting world. One of the things we've concluded, it's easy to have a vision for the end. I don't know that anyone has a vision for the end yet. So what we have determined on the task force is that we're going to be prepared to pivot wherever it's going. And we believe for the present time, there isn't one size that fits all, so we're trying to put ourselves in a regulatory position that we can embrace nuclear, we can embrace hydrogen. 1 year ago, if I were standing here, I would say electric vehicles are the end game. Two of our manufacturers, Cummins and Toyota, testified this last year it isn't the end game. A Purdue professor who testified said there's not enough lithium on the planet to do just what we're talking about in the United States. If we put batteries in semi-trucks, we take so much of the load for over-the-road shipping that it becomes unaffordable transportation. So Cummins has shifted to hydrogen research. Last year, we passed a sequestration bill. BP was the lead. Purdue is part of that. Almost everything that we are doing, Purdue is part of, and thank you, Dr. Chang and Mitch Daniels, for being willing to be on the point. So as we move forward with the carbon sequestration project, just after passing that legislation, not only do we have the consortium of which Purdue is a part, but we have about 4 other projects around the state moving forward, a cement plant, a steel plant. We have some further work to do. But again, once we open that door, and it appears that in a consortium with Michigan and Illinois, we're very competitive for a hydrogen hub here in Indiana. And when you look at the opportunities for hydrogen, just mixing them with natural gas, we reduce the carbon footprint significantly. And how we make that hydrogen, a number of us have become convinced that a very key part of at least the transition and probably the future is small modular reactors. And what we define as small is about to change. Last year's law was 350 megawatts. We have a manufacturer, I'm not sure it's public, but Senator Cook has sent me a bill that raises that to 470 megawatts. So we need what Purdue is doing here. I happened to be on the Safety Advisory Board at NASA when we lost the space shuttle. Having a failure like that set us back 5 years. Having a failure in our first SMR will set us back as much as Fukushima did in other reactors. Very different technology, but we have to get it right. And I was so pleased when we did the first legislation last year to direct the IURC to do our regulatory part to enable and encourage small modular reactors. I happened to be visiting Purdue, and Mitch Daniels said to me, you know, we're going to take a really good look at that. And I will tell you, I served under Mitch Daniels. When he says we're going to take a look at it, there's a whole lot of energy behind it. So, and I'm so happy that energy is happening here, because I know that Purdue's participation, we're going to look at it in depth, we're going to do it right, and we're going to avoid a significant problem. So thank you to the folks at Purdue, Thank you for all that you're doing, and I hope you will continue. Senator Cook and I have the door always open. Mike Klein and I go back a long way, and I have huge confidence in them and in the meetings I've had with Dr. Chang. I can't think of a better team to be teamed up with. So thank you for the opportunity, and thank you for the work you're doing.
Representative Soliday, thank you. We appreciate you being here and giving us that view shed into the work that's going on across Indiana. I'd also like to thank President Chang for your comments and participation here today. And I'd also, of course, like to thank Chris and Tim, Louise, Ahmet for your panel discussion, very informative, and it just seals the deal for us today to have that kind of dialogue here at Purdue University. So that concludes our session today, our lecture series, and thank you all. Cheers.